Our universe is unfathomably large, with billions of habitable planets in our galaxy alone, and there are an estimated 2 trillion galaxies in the observable universe. Given this, it is very hard to believe that life only exists on planet Earth. Despite such a high probability of extraterrestrial life, why haven't we found any evidence of aliens existing? Could it be that our tiny planet is the only place with meaning among septillions of stars? This is the Fermi Paradox, and there are several popular solutions to it. But one of them stands out as the most terrifying. It is the dark forest hypothesis. Imagine you are a hunter walking alone in a dense forest, deep in the night. Heavy mist clouds the air, making it harder to see and adding to the dead silence. As you move through the dark forest, you start feeling lonely. You wonder if there are others like you in the forest, lost and searching. But despite wanting company, you hesitate to call out. What if those in the forest attack you as soon as they notice you? Should you risk making noise, hoping for a peaceful interaction, or stay quiet, avoiding potential danger? This is how our universe is viewed in the dark forest hypothesis. According to it, in our dark and silent universe, alien civilizations keep quiet to remain safe, and those who have broadcast their existence have been wiped out. If this solution is true, meaning that every civilization is an existential threat to another, then there can be only 2 types of alien civilizations, silent or dead. This is what makes the dark forest theory terrifying. But are things really that bad? You might think that if we have a peaceful interaction with aliens, we could cooperate and avoid war. After all, history has taught us to be diplomatic instead of destroying each other. The only problem is finding a common language to communicate, right? Unfortunately, things would be more complicated than that. Firstly, even if we initially managed to have a friendly conversation, we would have no way of understanding the real intentions of each other. Moreover, we wouldn't be able to communicate in real time like we do on Earth. It can take hundreds of years for one message to arrive. The time it takes for messages to travel means both sides will likely live in uncertainty, worrying if they should be the first to attack. Let's assume that the other civilization resided on just one or a few planets. If we decided to attack them and sent cosmic weapons capable of destroying entire planets, they would have almost no chance to defend themselves, unless they quickly abandoned their planets and found new habitable worlds. Therefore, waiting for a response can be a huge risk. Adding to the uncertainty is the rapid improvement of technology. Imagine reaching out to a civilization 100 light years away. To understand the technological improvement that can be made in the 100 years that it would take for our message to arrive, consider this. The computing power that was used to send the Apollo 11 to the moon in 1969 was less than that of a modern-day calculator. Moreover, according to Moore's law, 100 years would mean a quadrillion times more powerful computing technology. We don't know the rate of improvement of other civilizations. By the time our first message reaches them, they may be much more ahead of us. So, what is the best move when it comes to contacting aliens? Let's apply game theory to understand possible outcomes. Imagine 2 civilizations, each populating one planet. Let's call them Planet A and Planet B. Imagine B captures a radio signal from A. B's choices are simple: ignore, reply, or destroy. If B ignores, they both carry on, missing a chance to connect but causing no harm to each other. If B decides to destroy A, it likely costs B almost nothing, but causes A infinite harm. But if B replies, they risk getting destroyed by A. Game theory shows that replying could cause infinite harm for B. This leads to the terrifying conclusion that the worst option for B would be to reply to A's message, because replying is the only scenario where the outcome can be infinitely negative for B. The only scenario where both A and B will always avoid harm in this game is when both of them remain silent and avoid any attempt to contact each other. Thus, game theory confirms the dark forest hypothesis. So, should we stay silent and avoid sending any signals into space? Unfortunately, it is too late. In recent decades, we have sent out quite a few messages. One example is the Voyager 1 spacecraft launched in 1977 by NASA. By the time this video was uploaded, the craft was over 24 billion kilometers from us. Voyager 1 will never return, so there is a chance it will be discovered by an alien civilization. For that reason, this craft has a golden record on board. This record contains sounds and images that represent our planet. It includes greetings in 55 languages, music from different cultures, and sounds of nature, like a kiss and laughter. There are also 116 pictures showing our solar system, Earth, and human life. To help aliens understand the golden record, NASA encoded instructions based on hydrogen, the most common molecule in space. These instructions explain how to play the record, guiding listeners through Earth's sounds and images. Another example is the Arecibo message sent in 1974 towards Messier 13, a star cluster about 25,000 light-years away. The message contains information about various things on Earth, such as a human figure, DNA, and the Arecibo radio telescope, all in the form of binary code. This message is going to have a very long journey, lasting at least 22,000 years. Although Messier 13 will have moved by the time our message arrives, the radio signal will still land somewhere near the center of the star cluster. Regardless, this message is a demonstration of our technological improvement rather than a serious attempt to contact aliens. This leads us to a question: should we worry about the noise we have made? So far, the signals that we have sent are just a whisper in the tiny part of the silent cosmos, and it is very unlikely that an alien civilization will notice us anytime soon. But the perception of aliens that we have created using our imagination is influenced by our own biases. Let's look at this issue from a different angle. Humans are driven by curiosity and desire to conquer, capable of causing devastating wars. Plus, we have often unintentionally harmed other life forms in the process, sometimes even pushing them to extinction. But what if other civilizations practice completely different values and priorities? Of course, it is logical to assume that any spacefaring civilization should be, to a degree, pursuing exploration. But what if they value other life forms no less than themselves? Or what if their main values are so bizarre to us that we can't even understand them? Of course, it is too early to worry about alien attacks right now, but perhaps we should be more cautious with the signals that we send into space. Besides the dark forest hypothesis, there are many other possible solutions to the Fermi Paradox. Maybe some alien civilizations are already aware of us, but they are beyond our understanding, much like we are beyond the understanding of insects. Or maybe other civilizations are just observing our progress, waiting for us to become advanced enough before they reveal themselves. Or perhaps aliens are simply too far away from us. After all, we have no clue how big our universe is. It might even be infinite.